So good day, everyone. You are welcome to Gala Science Academy. So our today's topic in physics is frictional force in mechanics. Let us look at what frictional what force. So look at the frictional force. It's a force which always opposes the motion of an object. So any force that is always oppose the motion of an object is called frictional what? Frictional force. And the frictional force is always take place on a rough what? Surface. It's the only rough surface that can experience what we call frictional what? Frictional force. But the smooth surface is a friction what? Frictionless. So in this topic, and end of this topic, you'll be able to what? To differentiate between applied force that is applied to move a body and a frictional force which is always oppose the motion of the what? Of the body. And at the end of this class, you'll be able to what? To distinguish between the static friction and dynamic what? Friction. And at the end of the class, too, we will also be able to what? To understand the concept below the law of static friction. And how are you going to determine the coefficient of what? Of static what? Friction. And the resolution of what? Of forces we have under what? Frictional what? Frictional force. So let us start from the what? From definition of frictional what? Frictional force. So frictional force can be defined through what? Frictional force can be defined as a force which acts between the surface and between the what? Surface of two body in contact for what? Contact and tend to oppose the motion. The what? Motion of one body over the other. See, frictional force is a force which acted between the what? Surface of two bodies that are in contact and tend to oppose the motion of what? Of one body over what? Over another. Yes, let me show you the what? The sketch for it. Yeah, assume this is a what? A rough what? A rough surface. And if I put a what? A block on this rough surface, this is the block. The block rests on the what? Rough surface. This, let me say, this place is rough what? Is rough so what? Surface. I said it earlier that what? The frictional force is always take place on a rough surface. So if a block of mass M is acted on what? Is placed on the rough surface, the weight of this mass is acted what? Downward. This weight is what? Is M what? mg. If you place the what? The block on a rough surface, the weight of the block is acting downward, which is what? Mg. And the reaction of the rough surface on the block is acting weight upward. This R here is what? M what? Mg. So the R is the reaction of the block from the rough surface is acted upward. From the Isaac Newton third law of motion, we say that what? The action and reaction equal and what? And opposite. Automatically, these are and weight, they are what? They are equal. Mg. Good. So if I now apply a force here, the force I apply here, let me call it what? Force P. Force what? P. This P that I'm applying here is applied what? Applied force. I want to use this force to what? To drag the block to move along this direction. So if I drag the block to move along this direction, the acceleration of the moving of the dragging block like this is what? Is A. Look at this what? This line. It tells us that what? The block is moving along this what? Direction. So once the block moves along this direction, this is what? The P, which is applied force to drag the what? The block along this direction. But from the definition of the word of frictional force, any force that is opposed the motion of the object in contact is called frictional force. So if the block is moving along this direction with the aid of this P, automatically the frictional force, which is what? Oppose. The word oppose we have here, that is what? It will what? We have it along the side. This is our FR. So this applied force is greater than what? The frictional force. That's why the block is what? Is moving. So this is the frictional force. Any force that opposes the motion of an object is called frictional what? Frictional force. So from this now, you can now say what? Where P we have here is apply what? Apply force to drag the block. But what is FR stand for? FR is what? Free what? Frictional force. What is the weight? W is what? The weight of the what? Of the block. And R is what? Normal. Normal what? Reaction. So this is what? The definition of frictional force. This explanation of frictional force in terms of what? Of diagram. So the next thing is what? Let us look at the what? Types of friction. Types of friction. Type of what? Of friction. So basically, there are two types of what? Of friction. We have the first one, we have what we call what? Static friction. Static what? Friction. This static friction, we can also call it what? Limiting friction. Limiting what? Friction. And the second part type of friction, we have what we call dynamic. That what? Dynamic friction. This dynamic friction, we can also call it what? Kinetic friction or sliding friction. Can what? Kinetic friction, or we can also call it what? Sliding. Or sliding what? Friction. So these are the two types of what? Of friction we have. If we are talking about what? About static what? Friction is the frictional force that is responsible for objects to be at what? At rest or stationary. But the dynamic friction is a friction that is what? Keep a moving body to become to the what? To the rest. That's what dynamic friction or what kinematics what friction. Any frictional force that is what? That is make a what? A moving object to the what? To come to the rest and convert its kinetic energy to its energy. It's called like dynamic friction. So the common example of this dynamic friction is a friction that we have it in a brake. If a car is moving like this, immediately you apply a brake to the car will what? Will come to the rest. And the kinetic energy of moving the car, it will now convert to the heat energy. So the frictional force that is applied to make a moving object to come to the rest, we call it what? Sliding friction or dynamic friction. But this static friction is a frictional force that make a body to be at what? At rest. So that even if you apply external force to it, the body will still be at what? At rest. Example of what? Of a moving car. Or example of what? Of a car. Of a moving car in a what? In a hill. Or example of a person that's standing like this without falling down. It's static what? Friction. Another example of static friction is what? A book that you put on the what? On the shelf. Is also a what? A static what? Friction. For every object at rest or in a stationary position, and you apply external force to it, and the body will need to what? To move, the friction is what? Is statics. But when a body is moving, frictional force that is stop the car or the body to be moving, we call it what? Sliding what? Or dynamic what? Dynamic free what? Friction. Let us look at what? The definition for static friction and the dynamic what? Friction. Yeah, for statics, static friction. Static what? Friction. So the static friction, it occur when an object is stationary. When an object is what? Still what? Stationary, an external force. And what? External force is applied. An external force is what? Applied to it, but the object, but the object does not move. But the object does what? Does not move. So it occurs when an object is what? Is stationary, an external force is applied to it, but the object does what? Does not move. So the friction is what? Is static friction or limiting free what? Friction. An example of a static friction, say example of static what? Friction, whose are one, we have a car on a hill, yes, a car on a hill. Two, we have a book on a shelf. A book on a what? Mm, Shelf, and those are the what? The two example of what? Of static what? Friction. The next one is what? Is dynamic what? Dynamic friction. What is dynamic friction? So the dynamic friction There are what? Dynamic what? Friction. We can also call it what? Kinetics or what? Or sliding what? Sliding friction. Like I said in what? A kinetic what? Friction is a frictional force. So it's a force that opposes the motion of what? Of an object when it's what? Already moving. This is a what? It can be defined as a what? Or it is a force that oppose that what? Oppose the motion that oppose the motion mm, oppose the motion of object which is already moving, which is what? Already what? Moving. The force that opposes the motion of an object, which is what? Already what? Moving, is called what? Dynamic what? Friction or static what? Static friction. And this force is a force, dynamic friction is a force which slow down the what? The object, already moving object, and it converts its kinetic energy to the what? To potential energy. Yes, can I put it this way? It's a, a force which, or is a force that slow down the object that slow down the what? The object and converts its kinetic what? Convert its kinetic energy into what? Its energy. And this dynamic friction is always less than static friction. It's always less than what? Always less than static what? Friction. So that is what the difference between static friction and what? And dynamic what? Dynamic friction. So after that, the next thing that we need to determine now is what? Is the coefficient of what? Of static what? Friction. The next one now is what? Coefficient sense of friction. What? Coefficient of friction is known as what? As mu. And coefficient of friction can be defined. This can be defined. Can be what? Defined as ratio of force applied. Applied what? Force, which is F, to the body. This force applied to the body. You know, I call it P here, Abi. But here I use what? F for it. The applied force is P, or we can also use what? Ordinary words, F. But we always use what? FR for what? For frictional force. So the force applied, the ratio of what? Of the force applied to the body to the weight of the body to the weight. What is the weight? W of the what? Of the body. The weight is what? Is of what? W. And we also know that, let me put weight. Weight. That this weight is equal to the what? To the normal reaction here. Abi? Therefore, we can also call it what? Weight of the body or normal what? Normal reaction of the body. What is normal reaction? Is what? R of the what? Of the body. So by interpret this statement now mathematically, what? Mathematically, the coefficient of friction will be what? Force F over what? Over weight. Or which is the weight is what? Is R. You can use what? Over R. This is the formula for coefficient of what? Of friction. So is the force applied to the what? Ratio of force applied to the normal reaction of the what? Of the body. That is what? How we can determine coefficient of what? Of friction. Let's solve one question on this coefficient of friction. So solution. Let us solve this simple question by applying the what? Coefficient of friction. A block of mass 10 kg rests on horizontal floor. So we are given that what? Mass of the what? Of the block is what? 10 kg rests on horizontal floor of coefficient of friction 0.4. The mu coefficient of friction is what? Is 0.4. What is the force will be required to just make the block to what? To move. So the force required to make the body to move is applied what? Force. Are we? This. So we know that what? The relationship between the force that is applied to take the body to move is what? F mu, or no, from this formula, you can say what? Recall that what? Coefficient of friction is the ratio of applied force over normal reaction, which is the weight of the what? Of the block. From this expression, you can have what? F equal to the what? Mu R. The applied force is the product of coefficient of friction and normal reaction, where are given that what? The mu, this expression is written as what? Mu mg. Back to this side. The weight equal to the mg, R equal to the what? Mg. So if you apply it here, you now have what? What is what? Mu given. Mu given is 0. What? Is 0.4. What is what? The weight. The weight given. Weight of this is what? Is 0. What? No, the weight. The mass of the block, M, is 10. G is also what? 10 due to gravity. Multiply this by this. We have what? 20. Let us press the calculator. Sorry, it's not 20. 10 times 10 is 100. 100 times 0.4 will give us what? 10 Newton. So the force applied required to move the block is what? Is 10 what? 10 Newton. So that is what about the what? The definition of friction, types of friction, and how to determine and the what? Coefficient of what? Of friction. The next thing that we are going to treat now is what? Experiments of how are we going to what? Experiment to determine the coefficient of what? Of friction. After that, we are moved to the what? Advantage and disadvantage of friction. From there, we now move to the what? The frictional force analysis. So let's go.